Carlos again, coming back to you for electric current video number 3. So in this particular case, I create an electric circuit. Now you're going to be doing this for a project. You're not going to have a fancy board with all sorts of little components like I have. But I'm going to use this board to show you how electricity works. So in order to have electricity, you need to create a source of electricity, a generator or a battery. In this case, we're going to use a battery. So right here I have a D-sized battery. It's about 1.5 volts. So that's how much potential it has. And it's polarized. It's got a positive side and a negative side. So somebody at a factory set this battery up and then inductively charged it. Now this is not a rechargeable battery, so they've inductively charged it. They put it in a field and pushed all the negatives to one side of the battery, and the other side is now positively charged. So it creates a field in this circuit. There's a positive side of the field, which is over here, and a negative side of the field, which is up here. Now when I let those electrons loose in a minute, what's going to happen is I'm going to hit this switch, and when I connect that switch together, the electrons are going to flow out of this battery through this light bulb, and when they go through that little filament, it's going to make it turn on. Now I don't know if you guys can see that on or not. It definitely is. And then it goes down through the switch, and then they come back to the positive side. Now this is called direct current, DC current, and the electrons flow. Now the current actually flows the other way, and you're going to go like, what? Why would the Coulomb guys swim upstream? Well, they swim upstream because they're negative particles. In physics, negative means goes the opposite direction. So when I'm playing with a Coulomb, when I'm playing with an electron, and I put it into a normally set up field, it's going to be retracted to the positive side of the field, right? Well, the field, if you remember from earlier in physics, is created in such a way that positive flows to negative. In static electricity, if I would have had more time, I would have really hammered that one home, but gravity works the same way. Things get pulled to the center of the earth. That's like the positive field pushing things down to the negative field. So negatives receive, positives give. That's the field. So that's the direction of the electrons. The field goes the other way. So we call it the current goes this way. Some people will say the positive charge flows to the negative part. I want to tell you what's really happening. The negatives are moving from the negative side of that battery, and they want to go home to the positive side. You just got to remember that they're swimming up current, up the flow. Now that light wasn't on very, very hard, right? It was like dim. I don't even know if you could see it. But if I took another battery, another D-sized battery, and I put it in this circuit so that you guys could experience it, 2 in a row, what would happen if I put them in series is what we're going to say. So in series, what ends up happening is I have 1.5 volt Coulomb guy that's sitting in one battery, and then the Coulomb or the electric field has now doubled in size. In other words, this positive side going this way and the negative side going this way, the difference in potential between those two is additive. So when I put this on, you're going to see that light bulb light up a lot better. Okay, when it lights up a lot better, that means it has more current flowing through it because there's a higher voltage. The resistance is the same. It's the same light bulb. So when we see this little light flashing like that, that's way brighter than it was a minute ago, and that's because I increased the field. So one of the things you're going to be doing in your project is creating a field. You want a bigger, stronger field? Use more voltage. I just doubled it by putting these in series, and I made that light bulb go from very bright, which you can see it's pretty bright, and now I'm going to take the light back off, because one of the batteries back out, because I'm not sure you noticed how much this made a difference. So when I connect it this time, you can see it's pretty dismal. It's not very bright at all, but it's right there. So the first thing you're going to need is some kind of source of power. Now, some of your projects might include cranking a generator, which is going to take a wire and a magnet to do that. So we could do that. Some of your projects might just include like putting wires of an LED into a potato or something. You're going to look online, you're going to find it, but you're going to find the source where you've created this potential voltage, positive, negative polarized field that sends through this wire and makes the negatives travel from negative to positive. Remember, swimming upstream so the current goes the other way.